All right, in this video, I want to teach you one of the most common, useful, simple patterns that you can use in LangGraph. And this is the pattern around creating ReAct agents, but doing it with function calling. So this is a fundamental thing that I see a lot of people make mistakes when they're designing their agents, is that they end up having lots of different nodes for doing different sorts of calls and function calls and stuff like that. And they try to have something like a reasoner where it decides if it's going to use math, if it's going to use search, if it's going to use this. And they end up with a graph that's really complicated. What you'll realize after this video is that really you can just do all of this with making one node yourself and then using some pre-built functions from LangGraph. So here we're going to basically have our reasoner node, which is going to decide if we're going to use a tool. If we're going to use a tool, no matter what the tool, we're going to go to the tool node. We're going to take the output of that tool, feed it back to the reasoner. If it decides it needs another tool, it will go again to the tool node. If it decides that it doesn't need a tool at all, it will just go to the end. This is one of the simplest patterns, but it's one of the most useful patterns that you can use. I'll start off by showing you a simple version of this, and then we'll add in a custom tool, and then we'll also make a custom state graph for this. So you can see how you can take the basics and then end up with something that's fully customized for what you want at the end here. Okay, so let's jump in and have a look at the code. So first off, you can see I'm just bringing in the standard stuff for LangGraph and LangChain. We're going to use DuckDuckGo in here. And we're going to start off with just a really simple ReAct function calling pattern of doing search and math. So it's going to be sort of an extension of one of the examples that they give in their docs. Before we do that, I wanted to show you the traditional ReAct prompt. You basically are doing something where you're asking it to decide if you want to use tools. You're passing in the tools so it knows what tools it has access to. And then you ask it an action step that's going to take, and it's going to provide an action input for that. So while technically what we're doing is not exactly the ReAct prompt, we're doing the same thing with the function calling in here, right? And to take advantage of that in LangGraph, we need to set it up the right way. So first off, we're just going to bring in a standard model in here. We've just got a chat model, and you don't have to use OpenAI. You could use some of the other ones in here as well. We're then going to set up some tools. So these are the tools taken from their docs. So you've got multiply, you've got addition, you've got divide in there. And then I'm going to throw in a different tool that we're going to basically just bring in the standard sort of DuckDuckGo search tool. And this is the simplest search tool that you can use. In a future video, I will talk a lot more about custom tools, and I will talk a lot more about like crafting your own tools. Although later on, we'll actually make a little custom tool in here as well. So we've got our DuckDuckGo search. You can see if I type in like, how old is Brad Pitt? We're going to get a bunch of information back about Brad Pitt in there. And we can see that in that information is going to be his current age. So next up, we want to bind those tools to the LLM so that the definitions of these tools, the schemas, etc., are going to go into the LLM so it can use them for function calling. So it can decide, okay, this is the function or this is the tool that I want to use. And remember, tool use and function calling are basically the same thing. It's just deciding which tool does it want to call, which is the same thing as deciding which function it wants to call in here. All right, we set up a simple system message where we're going to have your helpful assistant performing using search and performing arithmetic on a set of inputs. And then we've got the more sort of LangGraphy stuff. So the LangGraph stuff, we need to basically define the graph, we define the nodes, we define the edges here. Now, the whole thing that I'm trying to show you with this is that you don't need a lot of nodes to do this pattern. So you can see that the node that I've got here is this one node, the reasoner. This is going to take in a message state. So rather than using a type dictionary where we define everything that's going to be in the state, LangGraph has made this special state called a message state. And really, if we hover over it, you can see it itself is just a typed dict where it's basically adding in this message, and it's basically setting it up so that each time that we write to it, we're not overwriting it, we're just adding to the list in there. So you can see that this message state, we can take the LLM that we defined, we can pass in the system message and whatever messages that the model started off with. So we're going to pump in a message in there at the start, and then we can just call that And then we can return that to the messages variable on here. And we can see that an addable values dict in here. So that basically it's going to, whatever the response from this is going to basically be pushed onto this messages thing here. And then that node is done. It goes to the next node, or really it's going to go to the next edge that we're going to see. All right, so our nodes are done. Now we need to build the graph. So the graph here is being built where they're basically just taking in the message state. So this is like the pre-made dictionary for this. We're then going to add the nodes to this. So we're just adding a reasoner node and we're adding in a tools node. So where did this tools node come from? Okay, so this is one of the pre-built things here. So we're making use of two pre-built components from LangGraph. One is a tools node, and you can see that we just instantiate that by passing in the tools that we had up here, right? We've got the tools there. So it knows what tools are in there. It knows what tools to call, etc., as you go through. The other pre-built thing that we've got is this tools condition. This is just a function that we're going to use in a conditional edge, so that when we're adding our edges, so at the start, we're going to go to the reasoner. This is the node that basically decides, sends it off and gets back whether we're going to use a function call or not a function call. So if we just said hello or something like that, it's obviously not going to use a function call there. But if it's going to use a function call, we can see that, okay, we're going to come out of that and we've got this conditional edge. Now, normally in a conditional edge, we would decide, okay, we're going to this particular node or this other node here. Now we're using this tools condition. And if you look in the actual source code, you'll see that the tools condition really is no different than any conditional edge that we create ourselves, where it's just looking at the last message that got back. And if it was an AI message, it's basically saying, okay, was this using tools or was this not using tools? If it is using tools, it's going to return back the string tools. And we can see that then it's going to route it to the tool call or the tools node. And if it isn't, it's going to basically just send it to the end. So this is what's going on in here. So it can appear a bit like it's voodoo, that you don't know what's going on in there, but actually, really, it's quite simple what this is actually doing in here. Next up, we've basically got our last edge, which will always go from tools back to reasoner. So once we get told to do the function call and do a search, we go off to tools, we do the search, we get the results of the search, we pass it back to the model. And because we're passing in the history as we go along with this, right, we're passing in all of these messages, it knows, oh, okay, I asked for this particular function call and this is the result that I got back in there. So when we put it all together, you can see that we've just got a very simple graph, right? We're just going start to the reasoner. Reasoner, if it say hello, we'll just go to end. If you've got a tool use, it will go to tools and then we'll pass that back. Now, here's the thing is if it needs another tool call, it will then just go tools. So it's got this loop going on here. And we can see this when we come and run it, that now if I ask it, okay, what is 2 times Brad Pitt's age? So we know that we've got search that can get Brad Pitt's age. We know that we've got arithmetic that can put it together. Sure enough, when we look at the messages out, we can see that what did it first do? It first went and did a query to search on DuckDuckGo, Brad Pitt's age, right? It got that result back. This is the tool message that it got back. We can see then it decided his age is 60, which I think is correct based on December 16, 1963, even though it's saying 61 here. And it's basically done 2 times. That's the key thing I want you to see there. And then it comes back with the answer of that is 120. And so we get this answer out. 2 times Brad Pitt's age is 120 there. So this idea of this tool loop going on is the key thing. Now, if it only needed one tool, it would just use that and it would then end or after the final sort of call there. Let's look at a little bit more advanced way of adding our own custom tool. So I'm going to keep the tools that we've got here. I'm going to make a Yahoo Finance tool. So this is basically just get a stock price based on a ticker symbol. You can see that, okay, I'm just passing this in here. I was experimenting with different things passing in here. It seems to work well when you pass in the args that you want as well, rather than just this. So what we're going to do is we're going to get the ticker. We're going to look up the stock. We're going to get the previous close for that and return it. You can see here, if we test it, we're going to get out the last Apple price in there. Now, LangChain has a Yahoo Finance tool, but I find this not to work very well. You end up getting lots of news back, other things. It tends to confuse things in there. All right, this time I want to show you is that what if we wanted to do things a little bit differently? What if we wanted to make our own node and our own graph in there? So not using their pre-made graph in there. So, okay, making the graph, let me jump around a little bit. The graph here, I'm going to say, okay, we've got our query that we start things off at. We're going to have the messages exactly like they have in there, this whole idea of an annotated list. And this add operator, you'll see this used a lot for intermediate steps, but this add operator also can just add in all the messages we've got. And then we've got our final answer out. You could imagine we could add some things like finance in there if we wanted to save the numbers and push them off to something or do something else with it. But I wanted to show you that you can make your own custom graph dictionary there. And then using this on our reasoner node, because I just want to have the same number of nodes that we had before, I'm not going to try and make a lot of them. We're going to basically pull the query. We're going to pull the messages. We're then going to just put in the system message. So this is the same as before, except I've added in, you've also got access to the Yahoo Finance tool. And then we've basically got our message, which we're going to wrap as a human message in there. We're going to append that to the messages. So our message is going to have whatever our query is going in. And then we're going to invoke it just like we did before, right? With this LLM with tools in there. We set up our tools exactly the same as before. We're just adding in this get stock price. We set up the LLM with and bind the tools again. You can see if we look at the tools, we can see the new tool that we've added in here is this fifth tool is this get stock price and ticker and stuff like that. We can see, okay, what's going through to the actual model there. All right, I've talked about we set up our graph state in there. Finally, we just assemble everything in here. So I'm just calling this workflow where we're creating our state graph from this class that we defined up here. We add in our node for a reasoner. We add in the tools. I'm still using their pre-made tool node, very useful for doing that. And then I kick it off exactly the same as using their same conditional edge and putting it together. And you can see the graph is going to be the same as well. It's just, I've just now got the freedom. If I wanted to not come out with end here, I could go to other nodes and do other things in there as well. All right, let's try it out. So what is 2 times Brad Pitt's age? Sure enough, we get the same result back here. I'm just looking at the last message on the stack there. If I ask it, what is the price of Apple? You can see, sure enough, it just goes for get stock price, it uses the function calling, returns that. If I ask it, what is the stock price of the company that Jensen Huang is CEO of? So now we're starting to do multiple calls to this tool, but we're still just using that one tool node each time. And you can see, sure enough, it says, okay, what is stock price? We've got DuckDuckGo search first, asking Jensen Huang CEO company. And we can see that sure enough, it gets back from Denny's dishwasher to CEO of NVIDIA. So it works out that it's NVIDIA. It then does a stock price call on NVIDIA. It gets back the price for that. And then it finally gives it, then it goes back to the reasoner where it phrases it in nice natural language for us. The stock price of NVIDIA, the company where Jensen Huang is the CEO, is this. Again, if I wanted to use more tools, I can ask it, what will be the price of NVIDIA stock if it doubles? Again, it's got to basically get this. It's got this as then using our math tools in there. So very quickly, you can see that this really small little agent that basically is just doing like a ReAct pattern of looping through, but doing it with function calling, is able to get a whole bunch of information and return this. So this is something that you could even use as a subgraph, where you could basically have other graphs calling to this. You could have things in your app that just need to know certain information, call out to this, etc. And for a pretty small amount of code, you've now got something that can use a lot of different tools that you have in there, and you'd be able to call them in a loop and then get a nice natural language answer out. So if you aren't using this pattern already in your agents, you certainly should be. It's one of the easiest patterns to use, and it generally works very well. All right, as always, if you've got any questions, please put them in the comments below. If you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.